Alright chieftains, welcome back to part 2 of our video series, Strive for the 5. Today we're going to cover scientific notation and how to deal with these big numbers on the AP exam, especially related to the FRQs. They like using scientific notation because they're talking about global impact. And you're going to see all these numbers like 5.2 times 10 to the 11th or 2.5 times 10 to the 12th. Because it could relate to areas of Amazonia which are being cleared out or the decline of global reefs. So I'm going to explain these numbers and basically what they mean to you, and then also we're going to go over how to multiply and divide in scientific notation. It's a huge time saver. Keep in mind you only have about 20 to 22 minutes per FRQ, and you will have a total of 4 FRQs on the AP exam. So getting comfortable with scientific notation, what it does is it saves you a lot of time, and it gives you more time to look back on your FRQs and double check your answers. And it also makes multiplying and dividing really big numbers like millions and billions and even trillions really quick and really easy. So as you can see here, I have a bunch of stuff written on the board. I understand, like in the other video, you can't see it. So just as before, what I'll do is I will walk you through the video. This video should take about 10 minutes total. And just like in the other video, pay attention, take notes, watch it again if you don't understand something. Ask me any questions, and there will also be an assessment to help us practice our multiplying and dividing with scientific notation. Alright, so let's get started. Alright guys, so zooming in on the board here, you could see some whole numbers converted to scientific notation. For example, 100 is 1.0 times 10 to the second. 1,000 is 1.0 times 10 to the third. And 10,000 is 1.0 times 10 to the fourth. If you think about scientific notation, like 1.0 times 10 to the second, if you look at the exponent of 2 and you slide your decimal over 2 spots to the right, you end up with 100. Or if you take 10 to the third and slide it over 3 spots to the right, you end up with 1,000, right? So if we scroll down here and look at 52 million, all right, it's equivalent to 5.2 times 10 to the 7th, right? So a key aspect that I want you to remember for scientific notation is try to keep it in the one whole number, one decimal format. 5.2 times 10 to the 7th is the same as 52 million. 52 times 10 to the 6th, although it is correct, it's not the true format of scientific notation. So we're going to do everything in the one whole number format. Hence I underlined 1.0 and 5.2. Right? To convert that to a whole number, if you're more comfortable multiplying whole numbers, 5.2 times 10 to the 7th, what the exponent tells you is slide your decimal over 7 spots or add 6 zeros to get your whole number, and again you will end up with 52 million. Right? So as I was saying before, right, we're talking about really big numbers like 1 billion kilograms of carbon dioxide. On the FRQ, right, they're going to report it as 1.0 times 10 to the 9th. Why? Because it's easy and it's fast. And remember, if you're writing 1.0 times 10 to the 9th, as you continually work in math without calculators, it's going to save you a lot of time through 4 FRQs instead of writing 1 billion. Then imagine if you had to multiply that by 52 million, okay? So then if we slow down, or scroll down here, excuse me, you can see there's 250 billion hectares of global forest that have been cleared for the development of some type of economic purpose. So we could write 250 billion, all right, hectares of forest. All a hectare is, it's an area of 10 acres, right? So you will see that word a lot throughout this course. Or you could write 2.5 times 10 to the 11th. You're going to have to multiply and divide with 250 billion hectares of forest. Imagine carrying all of those zeros over, dropping zeros, crossing zeros out. It's possible you can make a mistake, but it's much more foolproof in my eyes if you work with 2.5 times 10 to the 11th. All right, so that should be a good little review for you. I'm going to stop the film here, and then I'm going to show you how to actually multiply and divide scientific notation. For some of you guys, this will be a review, and it's a good chance to go over this stuff so you don't make any careless mistakes. Alright guys, so let's take a look at how to multiply and divide in scientific notation. So let's say we have a question that's dealing with global coral reefs. You've done some volume calculations, right? Length times width times height. You converted something from millimeters into meters, meaning one number was divided by 1,000, like we went over in the other video, and you got a volume of 7.5 times 10 to the 8th cubic meters of global coral reefs. Now, each cubic meter, all right, has 2.0 times 10 to the third kilograms of calcium carbonate. What calcium carbonate is, that's basically the coral reef skeleton. You ever go to the beaches in Florida or the beach shops and they have those paperweights that are made of coral? They're that bleached, white, stony looking thing. That's calcium carbonate. So the FR people are saying, hey, what's the total density of calcium carbonate? So what you have to do is you have to multiply 7.5 times 10 to the 8th times 2.0 times 10 to the third. Right now you could convert those numbers to whole numbers. You can go 75000000000 and so on times 2000 times 2000. All right, and then you end up with this really big cumbersome equation. Or you could just take 7.5 times 10 to the 8th times 2.0 times 10 to the third gives you 1.5 times 10 to the 12th. Right, now think about it. You don't have a calculator, but 7.5 times 2 is 15. And then when you're multiplying in scientific notation, you're always going to add your exponents. Now I realize 8 plus 3 is 11. Okay, and you may want to write 15.0 times 10 to the 11th. Okay, but like we said before, keep it in one whole number. So what I'm going to do is I'm going to slide my decimal spot over 1 to the left to make it 1.5, and then I'm going to add one more exponent and end up with 1.5 times 10 to the 12th kilograms of calcium carbonate for our total global coral reefs. All right, so another example is, let's say there's 6.2 times 10 to the 6 pounds of coal, right? That's 6,200,000 pounds of coal in a total area of 3.1 times 10 to the third acres, right? So that's 3,100 acres. And the AP people want you to say, hey, how many pounds of coal per acre? And is it worth clearing all this forest and mining this area for this amount of coal? Now, when you're dividing in scientific notation, you don't add them. All you do is subtract them, right? So we could set it up like this. 6.2 times 10 to the 6 divided by 3.1 times 10 to the third. You don't have a calculator. But 6.2 divided by 3.1, you could do that in your head, or you could do it on some scratch math. It's 2, right? 2 times 3.1 is the same as 6.2. So because we're subtracting, you end up with 2.0 times 10 to the third pounds of coal per acre. Basically, you're getting very little coal, right? Think about an acre of land. Okay, that's about 4 properties in West Hartford. All right, he's going to give you 2,000 pounds of coal. That's nothing, right? And then we'll talk about, well, what are the environmental impacts of mining for this little coal, and what are all the negative economic impacts related with it? All right, so that's our quick lesson on multiplying and dividing scientific notation and understanding like what these numbers mean. So we'll summarize it real quick and we'll call this video a wrap. All right, scholars, thanks for logging on to watch my video series part 2 of Strive for the 5. As you can see, working with scientific notation is not very complicated. In fact, it's pretty easy, and it's going to save us a lot of time when multiplying and dividing big numbers that are on our FRQs. Remember, when you're multiplying in scientific notation, you're always going to add your exponents. And when you're dividing in scientific notation, you'll subtract your exponents. An important thing to keep in mind is, remember, you want to have one whole number and one decimal place, like we spoke about here. 1.5 times 10 to the 12th kilograms of calcium carbonate is the correct response, not 15.0 times 10 to the 11th. If you have any questions about this, you could always see me before class or after school, and I'll be happy to help you out. Be prepared for an assessment. You won't be allowed to use calculators, and go Chieftains!